What's up, guys? So today we're going to be finishing off chapter 1, or module 1, I should say, doing 1.10, the root of it all. And 1.10 kind of summarizes everything we've been doing, everything we've been learning, everything we've been practicing, groups it all into kind of one concise unit. So let's go ahead and let's take a look at this. So, number 1. Here, what we're doing is it's giving us information, and we need to kind of fill in the blanks and then graph our polynomial. So in number 1, it tells us the degree of the polynomial is 3. It's got a leading coefficient of -2, and it gave us the roots, right? In this case, it's -2 and 1 with a multiplicity of 2. So we need to know, does it have any additional roots? And the answer is no, because if we look at it, it's got a root of -2, which is assumed to have a multiplicity of 1, and 1 multiplicity of 2, which means the exponents from these roots are all going to add up to 3. Right? And we can kind of see that really clearly when we write the equation in factored form. Right? So it says it's got a leading coefficient of -2, so when we want to write the equation out, we're going to put that in front. And then just like we did in 1.9b, right, we're going to write out the factors given the roots. Right, so this root of -2 gives us a factor of x plus 2, and the root of 1 gives us a factor of x minus 1. But remember, because it's got a multiplicity of 2, this is going to be x minus 1 squared. So if we add up all the exponents, right, 1 plus 2 gives us 3. Now, to write it in standard form, all we have to do is write everything out, write all the factors out, and then FOIL everything together to get one concise function. Right? So we have this x minus 1 times x minus 1. We can FOIL that out, and we end up getting x squared minus 2x plus 1. Right? Then we have to distribute this x plus 2 inside of here. Right? So we do x times x squared, we get x cubed. We do x times -2x, we get -2x squared. We do x times 1, we get x. Right? And that's going to be plus 2 times x squared, which is 2x squared. 2 times -2x is -4x. 2 times 1 is 2. We can clean this all up, right? This -2x cancels out this positive 2x, right? And we have plus x minus 4x gives us minus 3x, right? So we have this -2 times x cubed minus 3x plus 2. We distribute that -2 in, and we get -2x cubed plus 6x minus 4, which is what we have right here. Right, then all we need to do is find some extra points so that we can plot an accurate graph, because we already have the degree, right? It's an odd degree with a negative leading coefficient, so that's going to be that S curve that has a negative slope. Right, we already have the roots and the multiplicity, so we know it's going to cross at -2, and it's going to touch at 1, because it's got a multiplicity of 2. So we just need some extra points, right? So we can find some, right, 1 before -2, and we can find one at -3, we get 32. We can find one in between -2 and 0, right, because we definitely want the y-intercept here. So this is definitely one we want to find. All right, but we can get -1, we'll get the y-intercept, we'll get one at, we already have one at 1, so let's find one after 1, which we'll pick 2. Right, so just some extra points, right? We want enough to where we're going to get an accurate graph. We can plot all those out, and then we just connect the end behaviors through all of our points to the next end behavior. Right? So let's keep going. But we're not going to spend a whole lot of time talking about graphing, because I know we've been doing graphing for a while, so we know what to do. All right, now this one, it didn't give us the degree of the polynomial, but it told us the leading coefficient and it gave us the roots. All right, so because we have the roots here, it gave us a root of 0 with a multiplicity of 2, and then it gave us the root 3 over 2, and then it also gave us the root -2 with a multiplicity of 2. All right, so let's do this. What if we wrote it in factored form first? Right, so the leading coefficient's -1, so we're going to write a negative out front. right? 0 multiplicity of 2, well, that root would give us the factor x squared, right? Because we can set it equal to 0, right? And then because it's got a multiplicity of 2, we would put a 2 in the exponent. Then the root of 3 over 2 would give us the factor of 2x minus 3. Because remember, we kind of work backwards, right? A root means we have x equals 3 over 2, and I want to solve it for 0. So I can multiply this 2 over, and I want to subtract this 3 over. All right, so that's how I got this 2x minus 3. And then we have a root of negative 2 with a multiplicity of 2. So I have x plus 2 all raised to the second power because it's a multiplicity of 2. All right, so now if we're looking at this, right, we have an x squared, 2x minus 1 to the first power, and x plus 2 to the second power. That tells us that it's got a degree of 5. And there's no additional roots because it doesn't give us an irrational number or imaginary number. So we don't know that there's going to be any other roots. So we just work with what we have. All right, so it's an odd polynomial, odd degree, and it's got a leading coefficient of negative 1. So it's a negative leading coefficient. So just like in number 1, it's going to have that S-curve that has that negative slope. All right, which means the end behavior is as x is approaching negative infinity, the function approaches infinity, right? As it's going farther to the left, it's also going farther up. And as x is approaching infinity, the function is getting farther down towards negative infinity. Right, now, the domain and range for this is going to be negative infinity to infinity because there's nothing that would give us a 0 in the denominator, and there's nothing really that stops our range either. All right, so because there's nothing kind of inhibiting us, we just have a domain and range of negative infinity to infinity. So all we need is some extra points. All right, so again, we just pick some supporting points based on the roots we already have. We have a root of negative 2, we have one of 0, and we have one of 1.5, or like that 3 over 2, right? So we just pick some points before it, pick some in between, and we can just plug that into our calculator, right? So we can punch this into that y equals, and then make a table, and that would be an easy way to find these extra points, just like we did previously, right? So we would just plot the roots, plot our supporting points, and because the end behavior is right, this is 81, this is negative 64, so that's way off the page, so we won't graph those. But it tells us a lot about the end behavior, right? So we would connect the end behavior. We know anytime it's got a multiplicity of 2, it's going to touch at that root, right? And then every time it's a multiplicity of 1 or any odd multiplicity, it's going to cross. All right, so just like we've been doing, nothing new here. We're just kind of putting it all together, right? So let's keep going. Number 3 here. Now, number 3, it brings some of those new theorems that we learned, right? It tells us it's got a degree of 4. The leading coefficient is 1, right? So it's even with a positive leading coefficient. So we know because it's even with a positive coefficient, right, we're going to have that smiley face, right? The roots given are the square root of 2 and the negative square root of 7. And if we remember, whenever we have irrational roots, we also are going to have the opposite of them. Right? So if we have the square root of 2, we're going to have negative square root of 2. And if we have negative square root 7, we're also going to have positive square root 7. So when we write the equation in factored form, we have to incorporate all of those different roots. Right? So this positive square root 2 gives us the factor x minus square root 2. And then this negative square root 2 gives us x plus square root 2. Same with the x plus square root 7 and x minus square root 7. So then we have to write it in standard form, which really isn't bad. It's just a lot of foiling, right? So we have this x minus root 2, x plus root 2. We would FOIL it out, right? And these square root 2 times x, those end up canceling. And it's almost the same problem in the second 2, except it's square root 7 instead of square root 2. All right, so we get some terms to cancel. And we're left with x squared minus 2 times x squared minus 7, which again, we would just FOIL that just like we FOILed the first problem, right? So we have x squared times x squared is x to the 4th. Negative 7 times x squared is negative 7x squared. Negative 2 times x squared is negative 2x squared. And then negative 2 times negative 7 is positive 14. Clean that up, and we have our equation in standard form. Right, so then all we would need to do then is find some extra points, just like we've been doing, right? We have our roots. We would just pick some points in between them. Right? And you can be creative with that, right? It's always easier since the roots are in that square root 2, right? We just punch that into our calculator. It's roughly 1.4. And then so negative square root 2 is negative 1.4. Square root of 7 is 2.6, roughly. Right? So we just got to be careful with how we're plotting these. But we plot them just like we've been plotting them. All right, so let's keep going, right? We found the extra points. We plotted all the points. We plotted the end behaviors. And then you just connect the dots. All right, so let's look at number 4. So here we have some imaginary numbers, right? It's got a degree of 4, a leading coefficient of 1, and the given roots are 2 plus 4 times I, 4, and 0. All right, so the only other additional root, because we have this imaginary number, we have to remember, if we have 2 plus 4 times I, we're always going to have 2 minus 4 times I as well. So writing that in factored form, right, we have a root of 0, so that's how we have this x. We have a root of 4, which is why we have x minus 4. And then this 2 plus 4 times I, that's how we got this x minus 2 minus 4 times I. Because if we remember, we'd write the root, or sorry, we'd write the factor for that as x minus 2 plus 4 times I, right, with the parentheses. But when we simplify it, this negative distributes into both the 2 and the positive 4i, which makes it minus 2 minus 4i. And then we would say the same thing about this 2 minus 4 times I, right? We write that as x minus 2 minus 4 times I, which turns it into x minus 2 plus 4 times I. Right? So if we want to just write it in standard form, right, we can do that. It's just a lot of foiling. So here we have it all written out, like all simplified, right? So we would just multiply each term by each term in the other factor, right? So we do x times x is x squared, x times negative 2 is negative 2x, x times 4i is 4ix, and we do negative 2 times x is negative 2x, negative 2 times negative 2 is positive 4, negative 2 times 4 times I is negative 8i, then we do negative 4i times x is negative 4ix, negative 4i times negative 2 is positive 8i, and then negative 4i times positive 4i is 16i squared, which remember, I squared is just 1, or sorry, is negative 1, right? So this negative 16i squared just turns into positive 16. Right, and we can clean this up, right? Negative 2x is going to give us negative 4x. Right, this x squared is just by itself. It doesn't cancel or add to anything. This 4ix minus 4x, that cancels. Then we have plus 4. Right, this negative 8i plus 8i, that cancels. So we have 4 plus 16 gives us 20. Right? Then all we would do is, here we have this x squared minus 4x, and we got that from distributing the x into this x minus 4, right? So x times x is x squared, x times negative 4 is negative 4x. All right, then we would just FOIL again, and it ends up cleaning up and getting x to the 4th minus 8x cubed plus 36x squared minus 80x. All right, so we would plug this into our calculator because we want some extra points. We know it's got a root of 0. It's got a root of 4. And then we don't really have to worry about the imaginary roots because there's no way to really plot them, so we just ignore them when we graph. All right, so we just pick something before 0, something in between 0 and 4, and then something after 4. All right, we plot the points, but we can tell all of these y values are going to be off the graph. So we just incorporate that into our graph, right? Before it gets to negative 1, it's got to be way up to 125, right? So it shouldn't cross negative 1 at all on this graph, right? And it's the same thing with 5, right? Before it gets to x equals 5, it should be all the way up at 125. So at no point in time should this graph cross that x equals 5 without being way off the graph, right? And then this 2 is at negative 64, right? So somewhere we know it's going to be way down below our graph. All right, but let's keep going. Almost done here. We got like 2 more. Number 5. Here we have the function x cubed minus 8x. All right, and if I want to know the roots and the degree of it, well, the degree I can kind of pull out right away, right? Since it's in standard form, you just look at the exponent. That's whatever is the biggest exponent, I should say. Right, and it's x cubed, so it's got a degree of 3. Now I know I'm going to want it in factored form, so I'm going to have to factor. I can pull out a greatest common factor of x, and I get x times x squared minus 8, right? So to find the root, what I would have to do is set that x squared minus 8 equal to 0, right, and solve. I already know one root is going to be 0, because I have this x in front. So I have x squared minus 8 equals 0. I would add that 8 over, so I get x squared equals 8. I can take the square root of it, and whenever I take the square root, remember I'm always going to have plus or minus. Right? And then I can split this square root of 8 up into the square root of 4 times the square root of 2. And I do that because I know the square root of 4 is 2. Right? So that gives me 2 different roots. I have positive 2 times square root 2, and I have negative 2 times square root 2. So writing it in factored form, right, I'm going to have x minus 2 times square root 2. That gives me this right here. And then x plus 2 root 2, which gives me this right here. Now I know all of them have a multiplicity of 1, right? Because the exponent is all raised to the first power. So all of these roots, they're going to cross. And then it's also got a degree of 3 and a positive leading coefficient. So that's why I have this S-curve with a positive slope. So as x is approaching negative infinity, I'm getting farther and farther negative, right, towards negative infinity. And as x is approaching infinity, I'm getting farther and farther positive towards infinity. All right, so all I would need to do is pick some extra points. Right, I have 3 roots. I'm already going to put those in my table. And then again, I'm just going to pick some points in between that'll help me plot an accurate graph. Right? I plot those points, I connect my end behaviors, and I have a pretty accurate graph. All right, so let's look at number 6, the last one, and we don't have to graph it. So here we're given the function x to the 4th minus 6x cubed plus 17x squared minus 54x plus 72. All right, it's in standard form, so if we want the degree, all we have to do is look at the largest exponent in the function, right? This x to the 4th, so it's got a degree of 4. Now it gave us the root of 2. So if I want to know the additional roots, what I'm going to have to do is use synthetic division, because I can't factor this using any method that I know of right now, right? But what I can do is I can divide, because it told me it's got a root of 2, which means that one of the factors is x minus 2. And I can divide to see what I have left in the function, and maybe I can factor that. All right, so if I divide by 2, I can use synthetic division here, right? So I put the root, or I put the 0 in the top left corner here. I write out all the coefficients. This is 1x to the 4th minus 6x cubed plus 17x squared minus 54x plus 72. And I just follow my procedure for synthetic division, right? I drop the 1, 2 times 1 is 2, negative 6 plus 2 is negative 4, and then I repeat, 2 times negative 4 is negative 8, 17 plus negative 8 is 9, and I keep going, right? And I get a remainder of 0. Right, so these, my answer here, they turn into the coefficient of the rest of the equation, right? So this was x to the 4th, so now it's 1x cubed minus 4x squared plus 9x minus 36. Right? And when I write this out, I can see I can factor by grouping, right? This x cubed minus 4x squared, I can pull out an x squared, and I get x minus 4. And then here I can pull out a 9, and I get x minus 4. So when I pull out the x minus 4 as the greatest common factor, I get x minus 4 times x squared plus 9. Right, so my other factor is x minus 4, right, which gives me a root of 4. And then this x squared plus 9, I'm going to have to solve that for x, right? I set it equal to 0, x squared plus 9, because this is how I find my root, right? I subtract the 9 over. I get x squared equals the square root of 9. Take the square root of it, but it's negative, right? I can't take the square root of a negative number. So I can kind of think of it as this, right? The square root of 9 times the square root of negative 1. All right, but again, I took the square root, so it's going to be plus or minus. The square root of 9 is 3. The square root of negative 1 is I. All right, so I have two new roots. I have 3i and negative 3i. So I can write those as factors as well. Right, it's got a degree of 4, and it's got a positive leading coefficient. So I know my end behavior is that smiley face, right? So they're both going up towards infinity. Right, and we'll go over the review problems in class a little bit, and we might make a video for them later. But that's all we wanted to cover for right now. If you have any questions, feel free to reach out. But great job today, guys. You guys did awesome.